In this problem, we're being asked to solve for x. And one thing that I thought would be helpful in so doing is to notice that we have a sine and a sine squared term. And by noticing that we have both of those, we quickly realize that we're not going to really be able to isolate one of them unless we do some fancy algebra. So I thought it might be good if we substituted the sine of x with a letter of our choosing. I'll choose W for Racilo. You can pick any letter you want there, but what that does is it changes the appearance of this problem into a non-trigonometric problem. At least now we can focus our energy on what would we do with this, in 8th or 9th grade when we originally learned how to do these. Well, one thing you can do here is factor the equation and then set each factor equal to 0. Classic quadratic equation move, right? And solving the second equation is easy, and the first equation there is already solved. So what we've done here is managed to solve this equation for W. Let's not forget, looking at the original problem, there is no W. It's x we want to solve for. But by solving this equation for the self-created variable W, I'm able then to take the fact that W represented sine x and replace those W's back with sine x's. You see, by doing this, we've isolated the sine twice, and now this equation is much easier to solve. Let's start with the first one. The sine of x equals 0 at infinitely many places. But looking at the top of your screen, because we're restricted to the interval from 0 to 2 pi, these are the only valid answers that come from the sine x equals 0 equation. A quick side note here before we go to the second equation. 2 pi would be a solution to the equation, but it wouldn't lie in the interval requested because the interval being requested is specifically x less than 2 pi, not less than or equal to 2 pi. Because of that part of the instructions, I will not include 2 pi as a solution here. Moving on to the second equation, sine of x equals -1, again at infinitely many places, only one of which is on the interval from 0 to 2 pi. So now that we've isolated and solved the equation for x, we are finished with this problem.